Assalamu alaikum and welcome to the Mathcast with Faria Yusuf. And today we will be doing more questions from past papers. But before doing these questions, we should be knowing some identities. We have discussed these identities earlier, but now here it's a comprehensive detail of all the identities that I have jotted down for the students. So complementary identity number one, sine of 90 minus theta equals cos theta, or if the angle is in radian mode, then sine of pi by 2 minus theta, which equals cos theta. Cos of 90 minus theta equals sine theta, or in the radian mode, cos of pi by 2 minus theta equals sine theta. This is just related to what we discussed in the introductory lessons, that sine of 30 shall be equal to cos of 60, or cos of 50 shall be equal to sine of 90 minus 50, which is equals to 40 degrees. Or tan 90 minus theta, that should be equal to 1 over tan theta, or tan pi by 2 minus theta equals 1 over tan theta here. Then we have the supplementary identity, and the supplementary identity, it's the second quadrant identity that we have here. Supplementary angle identity, that means we should be discussing all the angles which are in the second quadrant. So if the angles are in the second quadrant, then this is what we are discussing over here. So sine of 180 minus theta, sine of 180 minus theta, this is our 180 minus theta here. So sine of 180 minus theta shall be equal to sine theta. In the second quadrant, our sine is a positive, or sine pi minus theta equals sine theta in the radian mode. Cos of 180 minus theta is minus cos theta. Cos of pi minus theta is minus cos theta. Tan of 180 minus theta is negative tan theta, or radian mode, tan pi minus theta equals minus tan theta. Then we have the third angle identity. So we know the third angle identity, our angle, they need to be in the third quadrant. So if the angle is in the third quadrant, let's say that the basic angle here is a theta, then I can say that this is my 180 plus theta, or my pi plus theta, which is the general angle. So again, relating both of them, I should know that sine of 180 plus theta equals minus sine theta, because in the third quadrant our sine is a negative, or sine pi plus theta equals negative sine theta. Or in terms of cos, cos 180 plus theta shall be equal to negative cos theta. Cos is negative in the third quadrant. Or cos of pi plus theta shall be equal to negative cos theta. Tan of 180 plus theta in the third quadrant, tan is a positive, therefore it equals positive tan theta. Or tan pi plus theta in the radian mode shall be equal to tan theta. Fourth quadrant identity. So fourth quadrant, our rotation now is in the fourth quadrant here. So if this is the rotation in the fourth quadrant and my basic angle here is theta, then I should know that my general angle here needs to be 360 minus theta. So with respect to these two angles, now I should know that sine of 360 minus theta equals negative sine theta, because sine is negative in the fourth quadrant. Or in the radian mode, sine of 2 pi minus theta equals negative sine theta. Cos of 360 minus theta equals cos theta, positive in the fourth quadrant. Or cos 2 pi minus theta in the radian mode equals cos theta. And in terms of tan, because it's negative in the fourth quadrant, I should say tan of 360 degrees minus theta equals negative tan theta, or in the radian mode it should be tan 2 pi minus theta, which equals negative tan theta here. So these are basically the four quadrant properties that we have. And then it's the clockwise angle property, and for the clockwise angle property, sine of minus theta. So if I just relate it with respect to the rotation, then we know that the clockwise rotations, they are taken as positive. So if I consider this angle in the clockwise rotation, so I should say it's a sine of minus theta. So if I relate it to the anti-clockwise rotation angle, then basically I have the sine theta, which is a negative in the fourth quadrant. Therefore, I'm simply going to write here that sine of minus theta shall be equal to negative sine theta in terms of anti-clockwise rotation. Cos of minus theta, cos positive in the fourth quadrant, therefore cos of minus theta shall be equal to a positive cos theta. Tan of minus theta equals to positive, tan of minus theta then shall be equal to a negative tan theta here. Now, I have just explained this with respect to the fourth quadrant, but we can just analyze it with respect to each and every quadrant, first, second, and third, and we will see that our angle rotation will come out to be the same property, which is for sine minus theta equals minus sine theta here. So to solve to solve these questions, students should be knowing all these identities that I have jotted down, and you should know these identities on your fingertips. So let's start the question. The first question is from May June 2010, and it's paper 1 variant 1 and question number 1. And the question says the acute angle. We have the acute angle, that means we are talking about the first quadrant angles. Acute angle x radian is such that tan of x equals k, where k is a positive constant, so express in terms of k part 1 tan of pi minus x. So first thing that we should be knowing here is that this is the acute angle, and for this acute angle, let's draw the rotation here. It's the acute angle, therefore it's the first quadrant that we should be having here, and we have the angle which is x. And for this angle, if I simply drop a perpendicular, if I simply drop this perpendicular, then obviously I will be getting a right angle triangle. Now the question has given us tan of x, which is equals to k. So we know tan of x is basically equal to opposite over adjacent. So I can simply say that my opposite in this case is a k and my adjacent here is a 1. Tan of x equals k, so adjacent value obviously has to be a 1, so that I can just write it as a k here. So adjacent meaning this side it's a 1 and my perpendicular is going to be a k. With respect to this triangle, I can very easily find out the hypotenuse. I can say it's the h, which is equals to square root of perpendicular square plus base the whole square. I have the perpendicular, I have the hypotenuse as well, I have the base as well. So I'll just substitute the values and I can say it's a k square plus 1 the whole square. Or I can simply say that my hypotenuse here is square root of k square plus 1. So this is going to be k square plus 1 square root. So I have the lengths, I have the dimensions of all the three sides, the perpendicular, the base, and the hypotenuse. So the next thing is to start solving the question. For part 1, it says it should be tan of, part 1, we should say it's tan of pi minus x. So tan of pi minus x, we have already discussed that this is the second quadrant, the supplementary angle identity, and tan of pi minus x equals minus tan of x. I already have tan of x, which is given as a k, so I can simply say tan of pi minus x equals a negative k then. That's it. This is how it's supposed to be done, just a 1 mark question. Second question says, find out tan of pi by 2 minus x. Tan of pi by 2 minus x. So we are talking about the complementary angle identity, and the complementary angle identity says that tan of pi by 2 minus x can be written as 1 over tan of x. So if this is 1 over tan of x, then simply substitute the tan of x value here, and I can just say that this is going to be just 1 over k. That's it. That is going to be the answer. Now the third part. The third part of the question says find sine of x. So to find sine of x, we know sine of x is given as opposite over hypotenuse. Now for the opposite and hypotenuse, I should be considering the triangle, the right angle triangle that we have already drawn. So with respect to that, I can simply say it's sine of x, which is equals to the opposite, which is k, divided by the hypotenuse, which is equals to under root k square and a plus 1. So, so these are the simple questions, just 1 mark question that we are supposed to solve, and this is how, with respect to the identities, these questions get solved here. Let's move to the next question. The second question is chosen from May-June 2014, paper 1 variant 2, and it's the third question in the paper, and the question says it's the reflex angle theta. So if it's the reflex angle, that it can lie in the third quadrant and also in the fourth quadrant, and it is such that cos of theta equals k. Cos of theta equals k, and it's 0 less than k, which is less than 1. So they have defined this k value also, that k value has to be from in the range of 0 till 1. So in the range of 0 till 1, that means that k value is a positive value. So if k is a positive value, so just know that it's 0 less than k, which is less than 1. So all the k values, they are positive. It's the reflex angle, and we know that for the reflex angle, we are talking about the third and the fourth quadrant, and in the third quadrant our cosine is a negative. Our cos of theta has negative values in the third quadrant. Therefore I should be very much clear that they are talking about the reflex angle which lies in the fourth quadrant, and this then is going to be the theta value. So if this is the theta value, again I will be making use of the right angle triangle. So I have the right angle triangle here, and we know that it's cos of theta, which is equals to base or adjacent over hypotenuse. They have given us the cosine theta, which is equals to k. So I can divide this k by 1, and therefore I know that the adjacent value here is a k and my hypotenuse here is a 1. So adjacent here is a k, this is my adjacent, and my hypotenuse here is a 1. So with respect to that, I can very easily find my perpendicular by the Pythagoras theorem. I know that perpendicular is equals to under root h square minus base the whole square. So here I can say it's the perpendicular, which is equals to 1 the whole square minus k the whole square, or I can say that it's the perpendicular, which is equals to under root 1 minus k square. So we have the perpendicular value also, which is going to be 1 minus k square. So after doing all this simple working, there's part 1 says find an expression in terms of k for part A sine theta. So we have made this triangle in the fourth quadrant, and we know that in the fourth quadrant our sine theta has to have a negative value. That is because here I should say that my perpendicular should be having a negative sign because it's towards the negative y axis here. So if they are asking about this sine theta value, then I should say that sine theta equals opposite over hypotenuse, and this then shall be equal to a negative square root 1 minus k square divided by 1, or sine theta equals negative square root 1 minus k square. Part B is asking for tan theta. So again for tan theta, I shall be making use of my right angle triangle that we have already made. And part B, find out tan theta. So tan theta is a opposite or perpendicular over adjacent. Now in this right angle triangle, opposite is negative 1 minus k square the square root of negative 1 minus k square, and this then shall get divided by the k value. So my tan theta here shall be equal to a negative square root of 1 minus k square divided by k here. So this then is going to be a simple solution to this question. So we have to explain why sine 2 theta is negative for 0 less than k less than 1. So we already have a sine theta value, and sine theta value was a negative square root of under root 1 minus k square. We already have this value, which is a negative value here. So if they are saying find sine of 2 theta, then with sine of 2 theta, sine of theta that we have found was basically, for sine of theta, we were basically discussing the theta values which are between 0 and 360 degrees. So now if the question is asking for sine 2 theta, then this means I should be multiplying it by the second angle value, second rotation value. So that means it's a 2 times 0, which is a 0, and then it's a 2 theta, and then it should be equal to a 720 degrees. So that means we are talking about the second angle rotation 0 less than 2 theta, and which should be less than 720 degrees. So if this is a 700, if this is up till 720 degrees, and again they are asking for 0 less than k less than 1, then that means our cosine value, which was given in the question, has to be in the fourth quadrant. Our cosine value here, cos theta equals k, the whole of this triangle is based on this cos theta value, and this was from 0 till 1. That is why we have made it in the fourth quadrant, and the angle was reflex. That was another hint that we had. So if we give this angle the second rotation, so with the second rotation, obviously my angle then has to lie between 540 degrees. So if I give this a second rotation, so giving it a second rotation, I knew that this was 0, 90, 200, 180 degrees, then it was a 270 degrees, and then it was a 360 degrees. My angle value, my angle rotation was in this quadrant here, already decided and discussed. So if we are giving it a second rotation, that means we are talking about 540 degrees, and also we are talking about 720 degrees. And in this range from 540 till 720, giving it a second rotation, again our angle value will lie between 540 and 720, which is the fourth quadrant where our sine is going to be a negative. So we are simply going to write that the angle for second rotation will be from 540 less than theta, which is less than 720 degrees, less than 2 theta, less than 720 degrees, which lies in the fourth quadrant. Therefore, sine 2 theta is going to be negative. Sine 2 theta will be negative. So this is how this question is supposed to be done here. To practice more of such questions, you can just look for October-November 2013 Paper 1 Variant 2 Question 1, and also Summer 2015 Paper 1 Variant 1 and Question 1. Now another question that I have on my list is, next question that I have on my list is from Summer 2016 Paper 1 Variant 2, and this is question number 5 in the paper. So in this diagram, triangle ABC is a right angle triangle at C. So we can see it's a right angle triangle at C, and M is the midpoint of BC. M here is the midpoint of BC. It is given that angle ABC is equals to pi by 3. This angle here, it's a pi by 3 radian, and BAM, this equals theta radian. So denoting the lengths of BM and MC by x, find AM in terms of x. We are supposed to get AM in terms of x here. So if this is what we are supposed to find, then what we can see here is, so to solve for part 1, we are supposed to get AM. So this question will be done in 2 steps. First, we will be considering the triangle ABC. And if I consider the triangle ABC and if I just sketch it roughly, then what I know here is that A, B, and then C, it's a right angle triangle at C. The angle at B will remain the same, which is a pi by 3, and BC, we have the value of BC, we have the length of BC, which is equals to 2x. So first thing is to find A and A till C. So to find A till C, with respect to the angle pi by 3 given to us, I can say that it's tan of pi by 3, which shall be equal to AC, which is my opposite, over adjacent, which is my BC. So from here, I can very easily find my AC. And to find the AC, what I should know here is, so tan pi by 3 equals a square root of 3. AC is what we are supposed to find out, and BC is a 2x. Therefore, here I can say that AC is equals to 2 under root 3 and x. So this is what the value of AC is going to be. This is going to be 2 under root 3 and x. Then the question is asking for AM. So I will draw the line AM here, A till M. And we know that M till C, it was given as an x. M till C, this was given as an x. Again, if I consider the triangle AMC, then this is again a right angle triangle. And with respect to the right angle triangle, if I just redraw it, then we have A here, we have M here, and we have C here. MC is an x. AC we just found out to be 2 square root of 3 times x, and this is AM that we are supposed to find out. So using the Pythagoras theorem, I can say it's AM, which shall be equal to square root of AC the whole square, which is the perpendicular, and MC the whole square, which is going to be the base value. So here I can say it's AM, which shall be equal to 2 square root of 3x the whole square plus x the whole square, or I can say that AM then equals a 4 times 3 x square and a plus x square, or I can say that AM is equals to a 12x square plus x square, or I can simply say that this is my AM, which shall be equal to square root of 13x square, or I can say that this is square root of 13x here. So AM will be equal to square root of 13x. This is then going to be my answer in terms of x here. So for part 2 of the question, it says show that theta equals a pi by 6 minus tan inverse 1 over 2 under root 3. This theta equals pi by 6. Now this is the hint that is given to us. Pi by 6 is actually the angle for ABC. If C is a pi by 2 and angle at B is a pi by 3, then I should know that this angle here shall be equal to a pi by 6. Pi by 2, like I can say it's BAC, angle BAC, which then shall be equal to a pi by 2 minus pi by 3, which then shall be equal to a pi by 6 here. So angle at A is a pi by 6. Now this pi by 6 is the hint that we should be having here. And they are asking for this theta. We have to show that theta shall be equal to a pi by 6 minus tan inverse 1 over 2 under root 3. So if I consider this triangle, with this angle value as, let's say, equal to and m, then with this angle value as m, what I know here is that if I consider the triangle AMC, if I consider the triangle AMC, that then this angle at which is I have written as m shall be equal to MC here, which is an x. AC, we already found out AC, and that was a 2 under root 3x. So I'll simply write this as a 2 under root 3x. So from this triangle AMC, what I can say here is that it's tan of m, small m here, which shall be equal to opposite MC over adjacent, which is 2 under root 3x. So MC is an x and AC is 2 under root 3x. The x gets simplified, or I can simply say now that m shall be equal to tan inverse 1 over 2 square root of 3. Now another thing that I know about m is that this is basically pi by 6 minus theta, and this then equals to tan inverse 1 over 2 square root of 3, and we have to show that it's the theta value. Therefore I should say it's a pi by 6 minus tan inverse 1 over 2 square root of 3, and the theta is taken on the other side, therefore with the positive sign here. So here I can say that it is the theta which is equals to a pi by 6 minus tan inverse 1 over 2 square root of 3, and this is what we had to show. So therefore now we have proved that theta value here is equal to pi by 6 minus tan inverse 1 over 2 under root 3. So this is how this question was supposed to be done. So the next question says the diagram shows a triangle ABC. It's the triangle ABC in which BC is 20, ABC is 90 degrees. I can see that ABC here is a 90 degrees. It's a right angle triangle here. The perpendicular from B to AC meets AC at D. It's this perpendicular meeting AC at D, and AD is equals to 9 centimeters, and BCA, this angle here is a theta degrees. By expressing the length of BD in terms of theta in each of the triangles ABD and DBC, show that 20 sine square theta equals 9 cos theta. So here I can see that there are two right angle triangles. One of the right angle triangle is ABC, and another right angle triangle is BDC. And they are asking us to express the length of BD in terms of theta in each triangle ABD and also DBC, and we have to show that 20 sine square theta equals 9 cos theta. So we shall be solving the two triangles to get this question solved. So to get the length of BD, it's BD that is required, and this has to be in terms of theta. First, let's consider the triangle ABD. There are two triangles to consider. One is ABD, and the other triangle that they are asking us to solve for is DBC. So what I see here for triangle ABD is that if I get this triangle ABC, then this angle here is a pi by 2, and this angle here is a theta degrees. So with respect to this triangle ABC, if this is a pi by 2 and this is a theta, then here I can say that this value, this angle, this needs to be a pi by 2 minus theta here. So in triangle, let's go for triangle ABC first to get the angle A. So triangle ABC, angle A, the sum of all the angles is a pi, and this should be equal to angle A plus angle B and then plus angle C. So if I substitute all these values, then angle A is what we do not know, angle B is a pi by 2, and angle C is theta. Therefore, with respect to this, I can say it's pi minus pi by 2 and a minus theta. Pi minus pi by 2 is equal to a pi by 2. Therefore, angle A is equals to pi by 2 minus theta degrees here. So this is one thing that we know about angle A. So this will help us when we are solving triangle ABD, this angle pi by 2 minus theta. So for triangle ABD, if I redraw the triangle A, B, and then D, D is a pi by 2. We have angle A, and we know that angle A is equals to pi by 2 minus theta here. And we also know that AD is given as a 9 centimeters. So if they are asking us to get the angle value of BD, then angle value of BD shall be with respect to the angle A, which is a pi by 2 minus theta. I know that this is my opposite and AD is the adjacent. So in this triangle ABD, I can apply the tangent ratio and I can say that tan theta is opposite over adjacent. Therefore, tan of pi by 2 minus theta will be equal to tan BD, will be equal to BD over AD, and tan of pi by 2 minus theta shall be equal to BD over AD, which is a 9. Now there is one more thing that we can notice here, that we have the complementary angle identity for tan pi by 2 minus theta, and we know that tan pi by 2 minus theta is actually written as 1 over tan theta, which is then will be equal to BD over 9. Or simply I can say it's BD, which is equals to 9 divided by tan theta, or I can say it's 1 over tan theta, therefore it shall be equal to cos theta over sine theta. I'm writing it in terms of cos theta over sine theta because I want the entire equation in terms of sine squared theta and cos theta. So this is the value, this is the equation for BD in terms of theta, which shall be equal to 9 cos theta divided by sine theta here. So we have solved for the triangle ABD. Now next was to solve with respect to the triangle DBC, and if with respect to the triangle DBC, again if I consider the triangle, then I know that DBC is right angled at D. It's right angled at D here. This is angle B and we have a theta value here, or I can say that this angle value here is equals to a 20. So we have this as 20, and again we are supposed to find the length of BD, and with respect to the theta I know that this is going to be our opposite and this is going to be our hypotenuse. Therefore, opposite and hypotenuse, that is the ratio for sine theta. Therefore, I can say it's sine theta, which is equals to BD over BC. So BD then shall be equal to, BC is 20, therefore this equals 20 sine theta here. So we have two equations for BD, two expressions for BD, and BD is equals to 20 sine theta, as well as BD is equals to 9 cos theta over sine theta here. So to solve both of them, I have two equations of BD, therefore I can just equate both of them. BD equals 9 cos theta over sine theta, so I can say it's a 9 cos theta over sine theta, and this then can be equal to a 20 sine theta. Or I can say it's a 9 cos theta, which is equals to 20 sine square theta, and this is what the question has asked us to show. Therefore, rearranging them, I can say it's 20 sine square theta, which is equals to 9 cos theta, and this is now shown. So part 1 was 20 sine square theta equals 9 cos theta, which we have just shown for this question. Second part, hence showing all necessary working, calculate theta. So obviously, hence showing all necessary working, we will be using the equation from part 1, which was equal to 20 sine square theta equals 9 cos theta, to solve this equation, to solve the value of theta or to calculate theta here. So 20 sine square theta equals 9 cos theta. This is the second part of the question. So solving the second part of the question, it's 20 sine square theta, which equals 9 cos theta, and we know that unless and until the entire equation is in terms of one trigonometric ratio, we cannot solve the equation. Here it's a sine square theta, and this sine square theta now can be replaced by a 1 minus cos square theta, which shall then be equal to a 9 cos theta. Or here I can say it's a 20 minus 20 cos square theta, which shall be equal to a 9 cos theta. Or I can say it's a 20 cos square theta plus 9 cos theta minus 20, which then shall be equal to a 0. So I have this quadratic equation, but it's in terms of cos theta. Therefore, it's a disguised complex equation. I can just assume here that let m equals cos theta. So m squared then shall be equal to cos square theta. So I can have the quadratic equation as 20 m square plus 9m and a minus 20 here, and this then shall be equal to a 0. So solving the equation for 20m square plus 9m minus 20, I'm getting the m value as a 0.8 and also a negative 5 by 4. M is equals to cos theta. Therefore, I can say it's cos of theta, which is equals to 0.8, and cos of theta, which is equals to negative 5 by 4, which is greater than negative, which is less than a negative 1. So less than a negative 1, obviously cosine theta and sine theta, we know that they have to be, whether it's a sine theta or it's a cosine theta, they have to be in the range of negative 1 and 1. So any value which is less than negative 1 or any value which is greater than 1, sine and cosine ratios will not be possible. So here I can simply say that this cosine theta for negative 5 by 4 is not possible. Solving for cos of theta equals 0.8, I will be getting theta, which is equals to cos inverse 0.8, and cos inverse 0.8 is giving me the answer as 36.87, or giving the angle up till 1 decimal place, I can say that this is a 36.9 degrees. So this is how then this question needs to get solved. So this video was regarding all such questions which are for 2D diagrams or for all the identities. So we can see that we have applied the identities and we have solved for some 2D questions over here. So let's end this video, and in the next video we shall be doing the graphs of trigonometric functions. So just join me in the next video, and best wishes to all. Thanks for watching. Allah Hafiz.